Hello and welcome to my presentation for the Capstone project of the IBM Advanced Data Science course. Here we'll be dealing with the housing situation in Seattle. Namely, we'll try to find affordable yet safe housing. So let's begin with the problem statement. Let's say we are looking for flats which are affordable in their price and some parts of the city with low criminality, and so that they're close to some park nearby, because our clients would like to exercise a lot and would like to go to these parks quite often. So when it comes to the data acquisition, we would like to compare different Seattle neighborhoods by the following attributes. So when it comes to criminality, we will just use official sources provided by the governmental institutions. For the location of the districts, we wrote a small crawler in Python to get the geolocation of each district from the Wikipedia. When it comes to pricing, we can access Airbnb database from Kaggle computation. Proximity to parks is measured using Foursquare API. And for the population sizes of the districts, we will use Find My Seattle portal pages. We follow the rather traditional methodology, so we'll collect the data first, then we'll explore and understand the data, prepare and pre-process it, then we will establish a scoring engine which will give us which will identify which flats are desired. Then we will use that output as the input for the supervised learning model. So we will in a way mimic context-based recommender system. We will train our model and try to predict the flats which are desired. So let's first obtain the locations of the districts. So as I mentioned before, we will go to Wikipedia page which lists all the neighborhoods of Seattle, and then we will try to extract all the references mentioned there. So we will follow all the links and collect them and store them. Then when it comes to parks, we access Foursquare API. We can specify the category ID of certain property, which will give us the parks. So here we see a sample request, and we see that most of the parks are being marked in the Foursquare database, so it's a reliable source for that data. And the main problem with the data acquired from different sources is bringing it to sort of normalized form. So for our data sets, all the district names are different. So sometimes certain districts would be broken into smaller parts, or on the contrary, they would unite districts from the other data source. So for instance, here we can see that Ballard is broken into Ballard North and Ballard South. The same with Capitol Hill. We will find that sometimes we see southern part or northern part listed in some other sources, let's say for crime data and so on. So first step is to prepare the data and bring it to the same normalized form, so that we have the same district names in all of our data sources. Once we have done that, we can start taking a look at the data we have regarding the crime. So let's try to obtain the monthly breakdown of the crimes in each district. So here we see the data on the monthly basis, and the larger the circles are, the more crimes were committed in that time period. So we can see that it's an indication that Georgetown, Pioneer Square and Chinatown seem to be rather dangerous districts, and we would not recommend our clients to find the flats in those districts. Then instead of using that time series data, it would be easier for us to operate with just a single figure. So that's why instead of these time series data, we would much rather have just one figure for each district. So for that, we will use the 2-year rolling per capita as the attribute. So here is an example for one of the districts. It can be seen that having such a metric smoothes out the curve. So for our feature generation part, we will simply use the last value in the 2-year rolling as one of the attributes. If we do that, then here how it would roughly look like. As it was mentioned before, Georgetown, Pioneer Square, and Chinatown have the highest crime rates, and we have it now normalized by the population sizes, which we actually have retrieved from yet another data source from Find My Seattle portal page. And when it comes to mean price of the flats, that would be another attribute. So by retrieving the data from the Airbnb, we will measure what's the mean price of the flats in that district and put it on the map. Here it's a clear indication that Rainier Beach is the cheapest district in town, whereas South Lake Union is seems to be the most expensive. Then when it comes to the scoring engine, which would identify which flats are desirable, we do a simple formula which our clients have identified. So they would value park score with the weight of 1, then the price score with a bit higher weight because it's important for them to find affordable housing. They give even a higher weight to the criminality score because they wouldn't like to find some flats which are cheap and close to some park, but then that park is full of drug dealers. And then the overall score should be over a certain threshold, as well as the individual scores for some of the metrics should be above at least some threshold. So for criminality score, again, it's a bit higher than the other scores. And the scores are assigned according to simply percentiles of the attributes distribution, so that would allow us to be able to specify scores no matter the distribution. So for some of the attributes, we have seen that they follow Gaussian distribution, for others it's Poisson distribution, but using the percentiles would allow us to specify scores no matter what the underlying distribution is. Once we have these sort of flag in our data, we will feed this as an input to the neural network and try to teach it what is actually the desired flat in our case would mean. So we train the model by identifying those desired flats and then try to predict which flats are of desired property. So this way we kind of mimic content-based filtering with just a single user profile. So in real world scenario, we would have several users with their preferences, and we would need to build a more complicated system. But in our use case, we just follow this simple guideline. So for the model definition, we simply specify the feed-forward network, which has a sigmoid function as its output, uses binary cross entropy for the classification, and when it comes to training, we split our data into parts of 80% and for training the model and remaining 20% for testing. Then when it comes to evaluation, it can be seen that already having 30 epochs delivers quite high accuracy of 97%, and bumping up the number of input gates on the first layer to 30 delivers accuracy of 98%. This is of course way too easy for the neural network to figure out this dependency because it's just linear combination of some of the attributes, but it already kind of showcases the power of neural networks. When it comes to model deployment, Keras allows us to serialize the model into a JSON file or into a binary file, and then it can be deployed on the cloud. All of this information about my computations can be found on my GitHub page with a lot of time put into preparation of the data, normalization, also some analysis and filtering, because we filtered out some of the crime categories which were not of interest for our clients. Yeah, so thanks for listening, and yeah, have fun with the course.